What? Hello and welcome back to another video. In this one we're going to be talking about some strange dark corners of encodings in Unicode in Python. In particular, we're going to be talking about a very specific strange encoding that I'm going to call the snowman encoding. UTF snowman. But first let's talk about how I even discovered this strange oddity. I was scrolling, as I sometimes do, and stumbled across this gem. While poking at how this worked, I found a few strange things. Let's show what's going on here. Let's take the first example from the tweets. If we run this with Python 3, we'll notice that it succeeds. But wait a minute, doesn't that variable have a Unicode character in it? In fact, it does. In Python 3, variable names can have some Unicode characters in them, but in Python 2, they had to be entirely ASCII. If we run this with Python 2, we'll notice that we get a syntax error. If we look at the responding tweet and run it, we'll notice that it succeeds. Neat. And just to show you that there isn't any trickery going on here, we'll replace our UTF-8 encoding with the UTF-fake encoding. And when we run that, we'll notice that we get an error about an unknown encoding. The last interesting thing to note here is that if you're using Python 3 and the UTF-8 encoding, the encoding pragma is entirely optional. So what's going on here? PEP263 defines how source code is encoded. It roughly follows this strategy. First, open the file and search through the first two lines to find an encoding cookie, which tells how the rest of the file is encoded. The reason it uses the first two lines is this allows for a Unix shebang. Once it has determined the encoding from that cookie, or if it didn't find a cookie, it'll just use the default encoding, it will decode the rest of the file. If we take a look at the implementation of this encoding cookie, we'll find a regular expression. This regex matches in order, leading whitespace, a comment character, any number of characters, then the word coding, then either a colon or an equals sign, some more whitespace, and then any number of word or dash characters. This part is the actual encoding. If we take our two examples from the tweets, we'll notice that the first is detected as the UTF-8 encoding, and the second is detected as UTF. Now, UTF seems a little bit weird. Don't worry about that, we'll come back to that later. Just know that it works. Okay, so I've explained the original strangeness from the tweets. Let's get into the actual WAT for today. Note that all the examples that I'm about to show are run in Python 3. They all do still work in Python 2, but you'll need to prefix strings with a U. First, let's show how the encode method is supposed to work. If you encode a string, it converts it into bytes of that encoding. In this example, we take our snowman friend and convert him to his 3-byte UTF-8 representation. If you were to pass some sort of unknown encoding to the encode function, you should get a lookup error. I say should because while looking into the original tweets, I found a few strange things. What? Those encoding strings mean something, right? Snowman.encode UTF snowman? What? Okay. As usual, I explain what the heck is going on. Encodings go through a multi-phase normalization. The first phase is implemented in C in a function called normalizeString. It essentially lowercases the encoding and replaces spaces with dashes. I'm simulating normalizeString here with the lower function. The second phase, encodings.normalizeEncoding, essentially replaces a sequence of non-word characters with an underscore. Or if they're at the end, the underscore is dropped. And then the final phase is alias resolution. There's a mapping of known aliases in the encodings.aliases.aliases dictionary. So if we take our UTF snowman encoding, first it's normalized to a lowercase UTF snowman, then normalize encoding strips off the non-word characters, and so we get UTF, and then finally, UTF is resolved as an alias to UTF-8. And then it uses UTF-8. Anyway, thanks again for watching, and as always, have a good one!